Welcome to our discussion on rates and unit rates. Here are the objectives for this video. We want to be able to write rates as fractions because rates really are nothing more than a specialized use of a fraction, so make sure you're comfortable working with fractions. We want to be able to solve these types of proportional equations, which again is just a fancy way of saying working with fraction. And then unit rates really is just fractions reduced, so it's going to be a lot of work with fractions. Well, as I warned you, a rate is a fraction, and it's just a fraction that's used to compare two different quantities, and those two quantities don't necessarily have the same units. So a rate could be something as simple as, comparing pounds to pounds, but it could also be something that could be pounds per dollar. You want to figure out how many pounds of something you can get for each dollar, or miles per gallon, or miles per hour, all those things that I'm sure you've heard before. Well, anytime you hear something per, that's just the bottom half of the fraction. So that's a good tip to know. That'll help you set these things up is the miles per hour means miles divided by hours. Feet per second means feet over seconds. And miles per gallon means gallons goes on the bottom, right? So whatever comes after per goes on the bottom. Okay, let's look at an example. Suppose you and your friends are trying to figure out what to do. You've got three options. You can play laser tag, where you pay $13 for 2 games, or $18 for 3 games, or you can go to the county fair, pay $20, and ride all the rides you want. And you want to figure out, what's the best option based on the rates, and the rates are going to be based on time. So that's important. So we know it's going to be per time, right? So we're going to set everything up in price per time to kind of figure out what is the best. Now, since they told us it was number of games for money and then just getting into the fair for money, we have to like convert all those into units of time. So we're going to assume that a game of laser tag takes 30 minutes, and we're going to assume that we can go to the fair from 8 until 10 p.m. So now everything can be based on time. So when we talk about laser tag deal one, we pay $13 and we get to play 2 games, which is a total of 60 minutes, or $18 for a total of 90 minutes. And then if we bring in the fair amount told us that we paid $20, and for $20 we were there for 2 hours. But we don't want things in different units of measure. So it'd be better to think of it as $20 for 120 minutes. Now they're all the same thing, dollars per minute. And then you can compare to see which one is the best, right? Which one gives you the most bang for your buck. The easiest thing to do is to just throw them all into a calculator and look at the decimals. Or you can reduce all the fractions and then compare the fractions that. Okay, so here are all three reduced to decimals. Now, based on that, which do you think is the best deal, right? Which one gives you the most bang for your buck? Well, it's pretty obvious that it's either the largest number or the smallest number. So you better off with 0.216 or you better off with 0.16. And these little bars mean repeating, right? Well, you got to remember what's the unit of measure. This is dollars per minute. So for this type of entertainment, you're spending 0.216 or almost 22 cents per minute of entertainment. This one you're only spending 20 cents per minute of entertainment, and this one you're only spending, 16 and 2/3 or a little less than 17 cents per minute of entertainment. So doesn't that mean that the fair is the best deal? So if you're just looking to kind of maximize your entertainment dollar, the fair is the best way. Okay. How about this example where a certain store offers 30 pounds of candy for $64.49? Which of the following represents the rate given by this deal? And hopefully you're all saying, well, it's either B or D. Those are the only two logical ones because those are the only ones that have both 30 pounds and the amount. But do we do pounds per dollar or dollars per pound? That's the question. Well, it doesn't say anything about per, right? The question doesn't say which of the following represents the rate per pound or per dollar. And so because it doesn't give you any guidelines as to which way it wants to represent them, they're both accurate. This tells you pounds per dollar. So basically, this will tell you how much weight you get for every dollar, and this is dollars per pound. This will basically tell you how much money it is per pound. It's pretty much telling you the same thing, it's just in kind of opposite directions. How about this one? So Katie parents helped her buy her first new vehicle. She chose one that claims to have a fuel efficiency of 29 miles per gallon on the highway, and you can check the actual miles per gallon on her new car. If she drove 309 miles on 11 gallons of gas, what was her actual miles per gallon? Well, that's pretty easy. We just do miles over gallon and then reduce it or slap it into our calculator. And we get just a little bit over 28 miles per gallon, right? Miles per gallon because gallon's on the bottom. Now this one was obvious because it told us per gallon, and we figured out how many miles she gets per 1 gallon of gas. But what if it wasn't and you thought you could go in either direction? Well, if you wanted to do gallons per mile, you'd basically be asking the question, how many gallons of gas does it take to drive 1 mile? And then that's going to come out to be a fraction because all you're going to do is flip this. You're going to get 11 divided by 309, right? And that's going to be a number much smaller than 1. So just keep that in mind that it's not necessarily wrong, but it's telling you a completely different piece of information. It's not telling you how far you get on 1 gallon. It's telling you how many gallons it takes to go 1 mile. And for most people, that's not the way you want that information. Okay, how about this one? If rice costs $7.99 for 5 pounds, determine the cost per pound of rice. Pretty easy, right? You just take $7.99 divided by 5, and there's your price per pound. Now let's take it up a notch and talk about a proportional equation, which is again just fancy words for equations that have fractions in them. This is just one where we have one rate set equal to another one and then we solve, right? We figure out what's going on. So here's a typical example. How much gas should Katie have used after driving 243 miles in her new car that says she gets 20 miles per gallon? Well, we know 29 miles per gallon should be equal to 243 miles over some amount of gallons. So we set those two things equal and solve. It's very simple. Now I know many of you have probably seen these types of questions before and you've been told the trick or the shortcut of cross multiplying, right? That you just multiply the bottom of one fraction times that, the bottom of the other fraction times that, and that's how you solve these types of questions. And that's all well and good when they are these simple types of things. But what happens if you add a 3 out here or anything else? All of a sudden, this no longer works. You can't cross multiply. So instead of thinking about this as a whole different type of question that you solve with a whole different kind of set of rules, just follow my simple guidelines of anytime you have any equation that involves fractions, the number one thing you want to do is just get rid of fractions, which just means multiply by the bottoms of the fractions. And so you take the largest bottom and multiply by that first, kill off that fraction and any other fractions that might have other things, and then move on if there's any fractions that are left. And what happens is if you follow that more general set of rules, when you have something like this with extra junk on the end, you can still handle it because all you're going to do is come through and multiply everything through by x to get rid of the x, right? Then you're going to come through and multiply everything by 1, which is kind of silly. You know, this is over 1, so it really isn't a fraction. And then you can handle anything with fractions, not just this type of question. So if we don't have that 3, then we can do the cross multiplying, which is just a shortcut of multiplying everything through by the bottoms of each fraction. So instead, we'll put it back to the way it was, and then go through the cross multiplying type steps where you multiply both sides by x to get rid of that, right? And then you're pretty much multiplying by 1 to get rid of the 1, but divided by 1 is silly. So then you divide both sides by 29 to solve for x, and you get a little over 8, right? 8.38 or roughly 8 1/3. So it should take her about 8 1/3 gallons to drive 243 miles. Okay, a unit rate is a rate comparing two measured quantities, one of which is a single unit written in the denominator of the fraction. Basically the example we just saw before. So anytime you have a 1 in the bottom, right, that's the denominator of one of your fractions, you have a unit rate because it tells you how many things you have per 1 unit of that stuff. So in the previous example, we knew that she got 29 miles per 1 gallon. So that was a unit rate. Okay, let's see if we can find some unit rates. We're given the price of mulch three different types of mulch in three different amounts, right? 3 cubic feet, 2 cubic feet, 2 cubic feet. And we want to find the unit rate. And why would this be important? Why would we need to find unit rates of these three things? Well, maybe this is a real world situation where you're trying to decide which kind of mulch you want to put in your garden, and you want to know which one's the cheapest. And there's no way to tell when they're all based on different units. But if you put them all into unit rates, then you can compare prices. Same thing you would do in the grocery store if you were buying food, and you could buy chips that came in a 1 pound bag versus chips that came in a pound and a half size bag. They would obviously be at two different prices, but you can't tell which is the better deal unless you put them both into unit rates, like figure out what they both cost per pound or per ounce, that kind of thing. So this is actually an important real world topic. Okay, so all we have to do is take these things and make them over 1, which basically just means we're dividing by the number of things, right? We're just going to take 3.77 divided by 3 to figure out how much it costs per 1 cubic foot. And same thing for 398 and 333. We divide each of them by 2 to figure out how much they cost per 1 cubic foot. And if you do the math, you figure out $1.26 for the first one, $1.99 and $1.67. So obviously the cheapest rate is the $1.26 for the pine bark mulch. Here's your second skill check. Go ahead and pause the video and see if you can solve this one. Since they want you to just figure it out per hour, all you have to do is take that 1.5 and divide it by 24, and that'll give you how much went out per. And there's the answer you should have gotten. Now, obviously, if you're good with the metric system, you probably wouldn't want to talk about 0.0625 liters per hour. You'd want to convert that maybe to milliliters and figure out how many milliliters per hour it was. So it's not such a small decimal. It would actually be, a number. Just keep that in mind. All right, here's another example of something that could actually matter to you. Let's say you're traveling overseas and you're in Europe, a part of Europe that's on the euro, and you want to figure out how much stuff costs in relationship to your home dollar if you're from the United States, or if you're from any of these other places, you could compare it to whatever currency you have. Because when you go to buy let's say a hamburger for lunch and they tell you it's €3, you got to ask yourself, well, is that an okay price, or am I paying way too much for a burger? Well, you don't know unless you know how that compares to your home amount of money. So these are the exchange rates from a certain source at a certain time. A lot of travelers are confused by these rates because they give you kind of the rates in both direction, and actually in the real world these rates are different because it's usually the rates you have to pay to get your money exchanged, and that's different because there's a service fee kind of associated with it. But these are just the straight currency exchange rates on the stock market exchanges, basically, that it says. And this is how you read it. This means €1 is worth $1.35 roughly. So in order to buy a €1 currency, you would have to pay $1.35 US dollars, or 5.62223, a little over 5.62 pesos, and so on and so forth, right? The British pound, you'd only have to give them roughly 84 cents from a British pound, or $1.33 in Canadian dollars to get €1. That's how these things work. In the other direction, this would be kind of if you were selling your money back at the end of your trip. So if you had 74 euro cents, it would buy you $1, right? If you had about 18 euro cents, you would get 1 Argentinian peso. And if you had 75 euro cents, you could buy 1 Canadian dollar. So based on that, we could answer some typical questions like, what is the unit exchange rate for American dollars to euros, and then the unit exchange rate for euros to American dollars. We already talked about that. But if you were traveling and you wanted to take $200 for spending money, approximately how many euros would you have to spend at that point? And then our last question would be, what if you were over there and you saw something for 200 euros and you wanted to know, can I really afford to buy that? So you need to kind of figure it out in your own currency. Well, we already talked about how to answer parts A and B, right? We know that it's 1.35 euros per dollar, or 0.74 dollars per euro. That's easy. Let's move on to C and D. Part C, we want to figure out how much euro we're going to get for $200, and we simply set up our ratio and do our multiplication. And you can see that because we have a 1 here, that doesn't do anything. We're basically going to have multiply by x and then divide by 1.351. And all that's going to happen is you're going to have 200 divided by 1.31. You're basically asking yourselves how many 1.35s can go into 200, and that's how many euros I'm going to have when I exchange that dollar. And you're going to get roughly 148 euros. Now in the other case, part D, where we're trying to figure out how much it costs, we have to go the other direction. We have to use the other ratio. Now, if you don't want to have all these numbers recognized or memorized, you always could just use the 135 in the other direction rather than having to memorize, the 0.75 or have the table ready. But in any case, you're figuring out 200 euros is what, so you go in the opposite direction and you figure out that that 200 euro item is going to cost you about $270. It all comes down to putting your fractions in the right form, i.e. putting the right thing on the top and the right thing on the bottom. So just pay attention to the unit of measure. Make sure that when you're comparing things, the units are the same. If you have euros over dollars on the left-hand side, then you have to have euros over dollars on the right-hand side. You can't switch them around when you set up your equation because it's impossible for things to be equal if the units aren't in the same place, right? You can't have feet per second on the left equaling seconds per feet on the right. It's just not going to work. So that's the big place where people make mistakes. Other than that, it's just a simple matter of working with fractions and being careful, multiplying by the bottoms to get rid of them, and moving some stuff around and use your calculator.